Hi guys, in this episode of Shri series, we're going to be talking about how to calculate average relative atomic mass from a combination of atomic masses and their percentage abundances. Alright, so I'm going to use this example up here, but before I proceed any further, we need to understand what we need to do, what processes we need to follow in order to calculate the average relative atomic mass. Alright, now just a bit of an understanding. If you look at isotopes, all right, we know very well isotopes are compounds or atoms or chemicals that have the same atomic number but different mass number. All right, so if you look at examples of isotopes, for instance, carbon 12, carbon 13, and carbon 14, we know very well they have the same atomic number, which is 6, and my mass number will change. So in the first one it's 12, the other one's 13, and the other point is 14. So it's very important to understand that when you're calculating relative atomic masses from isotopes, you need to understand what the fundamentals are. Alright, so isotopes will have the same atomic number but different mass number. Alright, the next thing you need to look at is what we refer to as percentage abundances. Alright, now there are certain elements that you see on the periodic table that actually exist as isotopes. Alright, I just highlighted one, which is carbon 12, carbon 13 and carbon 14. You know very well they are isotopes of carbon. However, carbon 12 exists as a higher, I'll put an arrow up there, higher percentage compared to 13 and 14, and that explains why carbon 12 or the 12 is seen in your periodic table. All right, so when you look at this question above, all right, and I'll just read it out. 4 isotopes of lead and their relative atomic abundances are Pb204 1.4%, Pb206 24.1%, Pb207 22.1%, and Pb208 52.4%. All right, so we've been given the 4 isotopes. All right, so if you see here, the isotopes given there is 204, 206, 207, and 208. Okay, and if you look at their percentage abundance, so the 204 is 1.4%, 206 is 24.1%, 207 is 22.1%, and the last one is 52.4%. All right, so you can see that of the 4 different isotopes, the one that exists at a higher percent is the 208, which is 52.4. So if you look at this carefully, this can be converted into a mathematics problem, because you know very well that the average relative atomic mass of lead will incline towards 208. All right, it'll be something closer to that, because that tells you that this is the maximum. So it's between 207 and 208. So now this is me putting my maths hat on, but let's look at how we can work through this problem. All right, so you need to remember, you need to identify the atomic masses and the percentages in order to get the answer right. Okay, so let's look at the working. Okay, so what I would do here is I would say 1.40 divided by 100 multiplied by 204 plus 24.1 divided by 100 times 206 plus 22.1 over 100 207 plus 52.4 over 100 208. So it's very important that you connect the respective atomic mass, all right, with the respective percentage. So you can see 204 corresponds to 1.4, 206 corresponds to 24.1, and 207 corresponds to 22.1, and lastly 52.4 corresponds to 208. All right, and then from here onwards, you will see you just have to work this out mathematically. So that becomes working out here with using my calculator. And you will get something like 207.035. All right, so all you need to do is from this step to that step, you just have to use your calculator, and you will see that when you divide it by each of them, you're going to get the respective answer. If you're not too sure, you're welcome to check it again, because obviously when you're first working through these questions, you always get skeptical, but the most important thing is to ensure that you get the correct answer to help you work through that process. So you're going to get 207.034. Sometimes you might get another answer, 207.241, but the most important thing is to get this point right. Obviously, we will look at rounding off to 2 or 3 decimal places, but what I wanted you to understand from this question is you need to ensure the respective percentage corresponds to the individual isotopes atomic mass. All right, so that's basically how we work out calculating averages to get the overall relative atomic mass. All right, thanks for listening, guys. Bye now.